Hello, I'm Bukola Joseph. So, we are going to be talking about what you will be expecting to know before 2025 NECO Physics Practical. Okay, for question 2, you should please check out 2014 question 2 and 2018 question 2. Yeah, it will serve as a guide for this year question 2 Physics Practical. Okay, so but I'll be going through 2014 question 4. Okay, 2014 question 4, so I will guide you through that, but you should still check out 2018 question 2. Okay, I'm predicting that the experiment is going to be on this. Okay, so for this experiment you are going to be given the following apparatus: a ray box. This is a ray box with illumination in it, and then you'll be given a cross wire, either a cross wire or maybe optical pin to serve as the object. Okay, and then you'll be given a converging lens. This is a converging lens, and this is the screen. This one is the screen. I hope you can see what I'm doing. This is the screen S. Okay, this is the converging lens, and this is where the image will be formed on this screen. Okay, so now you'll be given a meter rule also to enable you measure object distance and whatever you are being asked to do from the question. So let me do a rundown through the instructions, and then I'll give you the general theory. Okay, general theory, so that even when you are doing the experiment and you see that your readings are not making sense, you will know that something is wrong. Okay, so this is it. Let me read the question. I'm going to read the instruction on 2014 question 2, past question. Okay, if you have this, you can check it out. So we have: you are provided with an illuminated object, converging lens, screen, meter rule, and other necessary materials. 1. Measure and record the size AO of the illuminated object. So the illuminated object will be on, there's a hole on the ray box, so it's going to be on that hole. Okay, you are expected to measure that object. Okay, and it's going to be what? AO. Okay, equal to. So based on this experiment, on this past question, we have AO to be 1.50 centimeter. Of course, you are going to be using your small meter, your small ruler. Okay, maybe from your mass set to measure. Okay, let's go. 2. Instruction 2 says, place the object O and the screen S on the opposite side of the converging lens L. So this is our converging lens, though I didn't label it. Let me do that. Okay, this is the converging lens L. Okay, so we have the instruction say place the object O, this is the object O, and the screen S, this is the screen S, on the opposite side of the converging lens. So this one is here, this one is on the other side of the converging lens. Let's go with the next instruction. Set the distance between the object and the lens U equal to what? 30 centimeter. So they say set the distance between the object. This is the object, not the ray box. You're not starting from here. The object is here, so you are going to take your measurement from this point. Okay, between the object and the lens. So you are going to use your ruler rule to measure the distance between this point and the middle of your lens holder. There will be a lens holder, the middle of the lens holder. Okay, it's going to be your U. You measure it to be what? 30 centimeter. Okay, so now let's see the next instruction. What does it say? Adjust the screen until a sharp image of the illuminated object is obtained on the screen. So this screen is something that is movable. So you move to the left, to the right. Okay, move to the left, to the right, until you can see a very sharp object on the screen. Okay, so if you are using a cross wire, you will see a wire on the screen, very sharp. Okay, not blur, sharp image. Okay, now if it's not a cross wire you're using, maybe two optical pin are being crossed like this, you will see the image on the screen. Okay, but it has to be a clear image. So that's all for this experiment. Then the next thing say measure and record the size A of the what image. So once you have adjusted the screen and then you are able to get a sharp image, you measure the image on the screen. So whatever you measure is what you record here. Okay, I think what they got is 2.2. Then a zero is added on it to make it to make it two DPs, two decimal places. Okay, so 2.2. Once you measure the image on the screen, 2.2. Okay, then you repeat. Okay, let me read the instruction. Let me go by the instruction. Repeat the procedure for four other values of u is equal to 35 centimeter, 40 centimeter, 50 centimeter, uh, and 50 centimeter respectively. 45 and 50 centimeter respectively. Tabulate your readings. Plot a graph of m inverse on the vertical axis and u on the horizontal axis. So usually when you are able to do the first experiment on your own via the instruction given, the next one is going to be a walkover because you've understood the first one. Okay, now the next instruction say repeat it for this, and this. So you will increase this length. You know it was 30 before. You will increase it to what? 30 with the help of a meter rule. The distance between the objects and the what? The screen. You increase it to 35. So once you have done that, the next thing is to what? Adjust the screen. You adjust the screen until a sharp image is formed. Once a sharp image is formed, you measure this image on the screen. Okay, so once you have measured the image on the screen, you record it. You can see they have 1.5. Okay, now this m is what? A over d. That's what you measured here. The image, the object size you measured, 1.5 divided by d. I think is divided by a. I mean, a divided by d. I'm thinking, where did they get d from? Where is d? Maybe it's typo. Sorry, it's typo. It's evaluate a over a naught. Exactly. So we have our a here. So it's going to be 2.2 divided by 1.5. You have this. Remember, this has to be in 3 DPs, in 3 decimal places, because it is evaluation. So for every evaluation you'll be doing in physics practical, it has to be in 3 decimal places. And so that is what you have here. So a divided by this, you have this divided by this, you have this. Okay, now m inverse. So you have m inverse simply means 1 over this. 1 over this gives you this. 1 over 1 gives you this. 1 over 0.800 gives you this. It has to be also in 3 decimal places. This reading has to be in 3 decimal places. You can see this one has no unit. You know why? Because a is in centimeter. A is in centimeter. A naught is in centimeter. Centimeter will cancel centimeter, and that is why there's no unit here. And this one also, since it's the inverse of this, is not having unit. This also would not have a unit. You know, we don't joke with unit in physics. It is important that you put your unit. Okay, now you can see that what after you are from the table of evaluation we have, okay, the table of observation, you can see that as the distance is increasing, what happens to the size of the image? The size of the as the object distance is increasing, the size of the image is what? Decreasing. Okay, which is logical. Theoretically, as the object distance is increasing, okay, the convergence also decreases. It decreases, and so the image also reduces. Okay, so of course you know what a converging lens is. Converging lens are those lenses that are thicker at the middle and smaller at the edges. Okay, they are thin at the edges, just like what we are seeing here. They are thicker at the middle. Okay, I hope you enjoyed today's problem solving or rundown. I'm still Bukola Joseph, the physics enthusiast. Bye.